So from a high level, that's going to change, but from a mobile backhaul and also fronthaul, that's also going to change. So remember, one thing that we said 5G is going to deliver is 1 millisecond of latency. And in order to do that, well, you need to have you need to re-engineer the network, basically. So right now, what we call the backhaul goes from usually the RNC all the way out to the BBU or the Node B, and the Node B consists of the baseband unit and also the radio units. And that's usually connected through what we call CPRI. So CPRI is a protocol that basically connects the radio and also the baseband control unit. Now, it's migrating to what we call CRAN, okay? So a centralized radio access network, and you can see on the left over here, the BBUs are going to be co-located within what we call a baseband hotel, where one server will probably host hundreds of BBUs, where that's going to connect towards hundreds and thousands of radio units. Now, there's a problem with that. So if CPRI is a point-to-point protocol, and with the increase of data rate, what's going to happen is the CPRI bandwidth is also going to increase by a huge amount. And you can see the current requirements and also the projected requirements in the future. We're going out to terabits that's required for CPRI. So it is very, very difficult. And one thing that people are looking at right now is, well, why don't we turn the fronthaul into a network as well? Instead of using CPRI, we can use CPRI over Ethernet. We can use radio over Ethernet. And Ethernet, we can easily get up to hundreds of gigabits and even in the future terabits. So the next generation fronthaul is really about moving the functional split point in the fronthaul to manage the data rate. Okay, so we're going to move basically all the BBUs together, and we're going to put a network to connect all the RUs. So the other thing I've already mentioned is CPRI over Ethernet and radio over Ethernet, and also the timing that's required to synchronize all these radios and et cetera, is going to be extremely tight. There's a presentation that talks about the timing requirements, how you're going to be engineering the timing requirements. It talks about something like 130 nanoseconds required in the fronthaul, and getting 130 nanoseconds is actually very, very difficult. So technologies like TSN, PTP, OAM will be able to deliver these kinds of requirements. So as I mentioned, the fronthaul, this is just a visualization of that. So you got the backhaul that goes from the IPFS core all the way out to the gateway router, which connects to the baseband hotel, which hosts a lot of virtual BBUs. That's going to connect to remote radio units via a fronthaul network, and as I mentioned, things like radio over Ethernet, CPRI over Ethernet, and also TSN will be involved in the fronthaul. So if you're interested in our products, I'm not talking about any products today. Go ask our colleagues what we do. We make test equipment for testing the backhaul and the fronthaul synchronization. But right now, we want to just basically give you a glimpse of what's 5G. If you have no idea what 5G is, hopefully today, after my presentation, you have some idea. It's really about giving greater speed, greater density, higher number of connections, lower latency, lower power to these devices. And everything needs to change. The radio, the core, the transport network needs to change, which is kind of good and kind of bad. It's good for us because we're in this technology, and something needs to change in order to keep us in the job, right? So initial trials have already been taking place, okay, and we do expect the first commercial launch of 5G somewhere in Asia, probably going to be SKT or China Mobile within the next 2 years, 2018 or 2019. So watch out for that. Okay, thank you very much. That's all I have, and have a nice day.